Hey, it's Miss Gill again. This problem probably won't affect too many of you. Somebody asked me about this problem. It is a bonus problem, but this girl, she's one of my greatest math students of all time, and I could see how she would be aggravated if she couldn't figure this out. So this video is pretty much just for this one student, but if you're curious and want to figure out how to do it, well, then here it is. So let's read the problem. This shape is designed using 3 semicircles. Kind of looks like the half of a yin yang. The radii of the semicircles are 3a, so that's the first one, 2a, and a. And they all combine to make this weirdo shape right here. You can kind of see it too. If I shade this one green, you can see it over here. That's the whole thing. And if I make this one blue, you can see it shaded down there on the bottom. And if you make this white one purple, you can see that it has been taken away. That's why it's a different color, because it's been subtracted out. So we're not going to include that in any of our measurements. We want to take it away. So find part A. Find the area of each semicircle in terms of A and pi, and show that the total area of the shape is 6 pi a squared. Okay, so I'm going to call this green shape here, I'm going to call it semicircle 1. I'll call the blue one semicircle 2, and I'll call the purple one semicircle 3. So if we're going to find the total area of our shape, we have to add the first 2 semicircles, but then subtract or take away the area of the third semicircle. So let me go ahead and write that formula. Our area for the shape is going to equal the area of semicircle 1 plus the area of semicircle 2, subtract, take away, minus the area of semicircle, is that an A? The area of semicircle 3. Okay, and we want to show, hopefully, that this is 6 pi a squared. So that's our goal right there. So what is the area of a semicircle? The area of just a generic semicircle, I'll write it up here at the top. The area of a generic semicircle is going to be 1/2 the area of a circle, which is pi r squared. Okay, so that's our formula that we're going to keep using. So for the green semicircle, I'm going to have 1/2 pi r. What is my radius here? 3a. 1/2 pi r squared plus the blue one is 1/2 pi 2a. That's the radius. 2a squared. Oops. Minus, might run out of space here. You tell? Minus 1/2 pi. Here our radius is just a squared. So that's our formula right there. Now if you remember, anything squared, like 3a squared, just means we're multiplying that thing by itself. So it really means 3a times 3a. And 3a times 3a is going to be 9a squared. 3 times 3 is 9. A times a is a squared. So let's clean this up a little bit. So we're going to have 1/2 pi. Notice how I'm not plugging anything in for pi, like 3.14, because it said to leave it in terms of a and pi. So if I want pi in my final answer, then I'm not going to plug in 3.14. I'm just going to leave it as pi. So now I've got 9a squared plus 1/2 pi. Now this would be 2a times 2a. So that's 4a squared minus, there's really nothing to clean up here right now, so I'm just going to rewrite it. Because a times a is a squared. Okay, let me erase this down here. Okay, now I'm going to get, do I got a little highlighter? Yeah. Is it big? No, it's really small. A little. There we go. I'm going to put the 1/2 and the 9 together. So that's going to give me 9/2. So then I've got 9/2 pi a squared. That way I only have one constant in the term instead of two. So I did have a 1/2 and a 9. Now I've just got one number, 9/2. So it's going to make it a little easier to work with. Plus, now I'm going to put the 1/2 and the 4 together. Well, that's easy. 4 times 1/2 is 2. I'm going to have 2 pi minus, and I only have one number over here anyway, so I'll just keep it that way. Okay, now if you look at the three terms, I've got something pi a squared plus something pi a squared minus something pi a squared. So these are like terms, so I can actually combine these like terms into one term. So I'm just going to do 9/2 plus 2 minus 1/2. And whatever that is, I just tack pi a squared to the end of it. Okay, so let's start with the 9/2 minus 1/2. So that would be 8/2. So I'm kind of using the commutative property here, switching things around. So 9/2 minus 1/2 is 8/2 plus 2. Bring that down. 8 divided by 2 is 4. And 4 plus 2 is 6. Which is exactly what I wanted. We had to show the total area was 6 pi a squared. So we're done with part A. That right here. Now part B says the area 6 pi a squared of the shape is 12 square centimeters. So it's giving us a number. Write an equation in the form A equals blah blah blah, leaving your answer in terms of pi. Okay, so all we've got to do is say that our area, 6 pi a squared, is equal to 12. And we're just going to write an equation in terms of A. I'll highlight that right there. So all we have to do is get A by itself and then we're done. Let me scroll down. So to get A by itself, I'm going to divide out the 6 pi. So to get rid of multiply 6 pi, I'm going to divide it. They cancel each other out. So I've got A squared equals 12 divided by 6 pi. To get rid of a square, we use square root. Now, normally when you square root something, it gives you two answers, like the square root of 12 over 6 pi positive, and then also the negative version of that. But in this case, A can't be negative because then our radius of this circle up here would be negative, which wouldn't make any sense. Like 3 times -1, you wouldn't have a -3 radius. So we're gonna throw that option out, the negative option. Just ignore it. So we're gonna say that A, because the square and the square root cancel each other out, equals the positive square root of 12 divided by 6 pi. We can clean that up a little bit because we know what 12 divided by 6 is. It's 2. So now we've got 2, and the pi is still on the bottom. So we just canceled that out, and that 12 divided by 6 is 2. 6 divided by 6 is 1. So now we've got 2 over pi. So A equals the square root of 2 over pi. So that was a pretty tough problem, so you can see why it's a bonus problem now. But that's it. Thank you for watching. Bye.